Yeah, good morning all. Now I would like to discuss about KVL. Okay, the statement of KVL is the algebraic sum of all voltages in a closed loop is equals to 0. That is V is equals to V1 plus V2 plus V3. Right? We need to verify this condition here. Okay, that means here V is equals to V1 plus V2 plus V3. Now see here, already theoretical calculations are completed. For 10 volts, V1 value is 1.53 volts and V2 value is 3.36 volts and V3 value is 5.04 volts. Similarly for 15 volts and 20 volts, already we are calculated theoretical values. Okay, now we will connect the practical circuit diagram. Okay, verify the KVL experiment. Okay, for this experiment, see here, I need RPS. Okay, the purpose of RPS is to get variable DC supply in the range of 0 to 30 volts. And to measure the voltage, here I am using 3 digital voltmeters. Okay, next to connect the circuit, here I am using a breadboard. The purpose of breadboard is to connect the circuit. The purpose of breadboard is to connect the temporary circuit diagrams. Okay, now see here first of all, from this given figure, supply positive terminal is connected to the 1 kilo ohm resistor starting point. Okay, see here supply positive terminal is connected to 1 kilo ohm resistor starting point, right? Here it is 1 kilo ohm resistor starting point. Okay, now observe the figure. Supply positive terminal and 1 kilo ohm resistor starting point and first voltmeter positive, all are connected at common point, right? These three common points will be connected in same column of the breadboard. See here, 1 2 3, same column of the breadboard. This is resistor starting point and resistor ending point is connected at another point. Okay, at this point, see here, this is first voltmeter V1, second voltmeter V2 and third voltmeter V3. Now see here first voltmeter positive terminal is connected here. Okay, 3 terminals are over, that is RPS positive, right? Resistor 1 kilo ohm resistor starting point and voltmeter positive. Okay, next voltmeter, first voltmeter negative is connected to the ending point of 1 kilo ohm resistor. Okay, next at this point again another 2.2 kilo ohm starting point is there, right? Okay, then here it is 2.2 kilo ohm resistor starting point and this 2.2 kilo ohm resistor ending point is connected at another port. Different points will be connected in horizontal line. Okay, again here at 2.2 kilo ohm resistor starting point, second voltmeter positive is connected. Okay, now see here first resistor ending and second resistor starting point, second voltmeter positive, first voltmeter negative, 4 points over, right? Next this 2.2 kilo ohm resistor ending point is connected at one point. Okay, again at that point second voltmeter negative, next at that same point 3.3 kilo ohm resistor starting point and 3.3 kilo ohm resistor ending point is connected at another different point. Okay, now see here again third voltmeter positive is connected at 3.3 kilo ohm starting point, right? Another resistor of 3.3 kilo ohm is connected. Okay, after that, third voltmeter negative is connected to 3.3 kilo ohm resistor ending point, or I can directly connect to ground. Voltmeter, third voltmeter negative is connected to ground, and this resistor ending is also connected to ground. Again, RPS negative is also connected to ground. That is about connections in case of KVL. Okay, now connections over, right? Now coming to the procedure, see here, observe the figure. Connections are made as per the circuit diagram. Okay, connections are made as per the circuit diagram. Switch on the power supply. Right, initially voltage course and voltage fine values in minimum position, and current limiting value should be in maximum position to avoid overloading. Right, now see here, connect the circuit as per the circuit diagram. Switch on the power supply. By varying the RPS, right, by varying the RPS in steps of 10 volts, 15 volts, 20 volts, and note down corresponding V1, V2, V3 readings. Okay, now observe here, by varying RPS in steps of, see here, this is course value to vary the supply voltage, this is fine value to vary the voltage value accurately. That means in steps of 0.1, 0.2, for that purpose we need to vary fine. Right, here 9.8, right, to get exact values in points or decimals, where I can vary fine, right, 10 volts. Now observe here, for 10 volts, here V1 value will be 1.53 volts, V2 value will be 3.3 volts or 3.2 or 3.3 volts, that is slightly varying. Next, V3 value is 5 volts. Right, similarly vary the supply voltage to 15 volts. Right, here RPS voltage will be, supply voltage is 15 volts. Right, now observe here the readings. V1 value is 2.2 volts, V2 value is 4.9 volts, V3 value is 7.5 volts. Okay, similarly vary the RPS voltage to 20 volts. Okay, note down the corresponding voltmeter readings. That is, again V1 value will be 3 volts, V2 value will be 6.5 volts, V3 value will be 10 volts. Okay, in this way we have to do the experiment. Okay, after taking the readings, okay, same way reduce RPS voltage to 0. Okay, reduce RPS voltage to 0 and switch off the power supply. Okay, in this way we have to do the experiment on Kirchhoff's voltage law. Okay, now observe from this tabular form. See here, 10 volts is equals to 1.53 plus 3.3 plus 5, that is 8.3, plus 1.53, approximately 9.83, that is approximately is equals to 10 volts. KVL is verified practically. Similarly, for 15 volts, V1 value will be 2.2 plus 4.9, that is 7.1 plus 7.6, approximately 14.6 or 14.7, that is also approximately equals to 15 volts. Similarly, for 20 volts, 3 plus 6.5, 9.5 plus 10, 19.5, 20 is approximately is equals to 19.5, right? Hence, KVL is verified theoretically as well as practically. Okay, that is about KVL. Thank you all.